Hi everyone, thank you for joining me today. My name is Mihal Kingston and I work on the NGINX open source projects that help users manage application traffic in Kubernetes environments. In my role at F5, and for those who are unaware, F5 acquired NGINX back in 2019 and F5 continues to be a core sponsor of NGINX open source projects. So in my role, I support projects like NGINX Ingress controller and NGINX Gateway Fabric, which is our Gateway API implementation. And both of these projects are developed in the open with contributions from the broader community. So I really appreciate you taking the time today to hear me speak. We've seen a lot of confusion over the past few months, especially around the retirement of Ingress-NGINX. So my goal today is to help clear up some things, give you all a clear picture of what is happening in the Kubernetes networking space. So before we get to the agenda, I would like to clear one important point. The NGINX project itself is not being retired. Only the Kubernetes community, Ingress-NGINX, Ingress controller, is being retired. NGINX continues to be actively developed and widely used across all kinds of environments, from virtual machines to bare metal servers to containers and of course Kubernetes. So that being said, this is what I'm going to cover today. So first of all, we'll clear up some of the confusion around the Ingress-NGINX retirement, what the announcement actually means, what it doesn't. Then we will talk about the Ingress era. What is an Ingress controller? What is an Ingress API? And why it became central to Kubernetes networking, and where it still fits today. Then we'll talk about the Gateway API itself. Why is everybody talking about the Gateway API now, and how it changes the way we think about traffic in Kubernetes. We'll then compare the Gateway API to the Ingress object, and we'll have a look at a side-by-side comparison between the two to understand the differences in approaches. Then we'll cover NGINX Gateway Fabric, which is F5's Gateway API implementation from an NGINX perspective, and how that fits into the broader ecosystem. And finally, we'll go through a few migration strategies and real-world considerations that need to be taken into account for folks migrating from Ingress-NGINX to Ingress or to another Gateway API implementation. So by the end of this, you should have a clear picture of the current landscape and how to navigate this transition with confidence. So I think a lot of you may recognize this image. So when the Kubernetes community announced the retirement of Ingress-NGINX, confusion rippled across deployments worldwide. Many teams didn't realize that there was an option, an actively maintained Ingress controller by the NGINX team. Some thought NGINX was going away entirely. These are claims and incorrect information out there that are not very accurate. Others were worried that the Ingress API itself was being deprecated, which isn't true either. So Ingress-NGINX is the Kubernetes community-maintained Ingress controller. It is scheduled for retirement in March of this year, 2026, and the decision comes from a lot of long-standing challenges in sustaining the project primarily, which has relied on a very small group of volunteers working in their spare time. The pressure of the project increased after severe vulnerabilities were discovered, including the Ingress nightmare recently. But after March 2026, there will be no updates or bug fixes or security patches, so that may leave existing deployments vulnerable to unpatched exploits. Now, this does not mean that things will stop working. Traffic won't be affected, workloads will continue to function. But the risk is that running unmaintained software in production does carry some significant operational and security risks. But the retirement also signals a broader shift in the Kubernetes ecosystem, especially towards the Gateway API, which offers a more modern and extensible approach to traffic management in Kubernetes. But for teams currently using Ingress-NGINX or who are looking at options to migrate to other implementations, now is the right time to start planning a path forward, just to avoid security exposure, compatibility issues, and so on and so forth. So many of you using Ingress-NGINX today are most likely evaluating alternatives right now, ones that have active development, robust security patches, and options include the F5 NGINX Ingress controller, NGINX Gateway Fabric, Traffic, HA Proxy, Kong, and Envoy-based controllers. There are many of them out there. They all have their own distinct advantages in terms of features and community support and enterprise readiness, of course. Now, this is a very familiar Spider-Man meme that you all know, but it's used quite frequently. But this time, it is warranted because both of these projects use NGINX under the hood as the core proxy, and they have very similar superpowers or features. Some of you may know that F5 does maintain an open source, permissively licensed NGINX Ingress controller. And just a fun fact, this started as an intern project back in 2016, and this was prior to the acquisition by F5. And that project is still actively maintained, open source, Apache 2.0 licensed, and it will stay that way. There is a team of dedicated engineers working on this with a bunch of upcoming features and upgrades. So if you're already comfortable with NGINX, especially those using Ingress-NGINX, and just want something that is familiar without a massive learning curve, we do believe that the F5's NGINX Ingress controller implementation is a good choice. Could be your smoothest path forward. So to repeat, NGINX is not retiring. We have an open source NGINX Ingress controller maintained by F5, and the NGINX engineering team work on that with community contributions welcome, of course. It's not Ingress-NGINX, that's a separate project. That is the Kubernetes community project that is retiring. So hopefully that clears up some confusion. The truth of the matter is that NGINX itself, as well as NGINX-based Ingress controllers and Gateway API solutions like NGINX Gateway Fabric, they are alive and thriving in the open ecosystem. NGINX Ingress controller is actively maintained and tested frequently. NGINX Gateway Fabric, the Gateway API implementation, is maturing very, very fast, conforming to the Gateway API specification, and it uses the same NGINX proxy under the hood as your gateway from a Gateway API perspective. So we'll talk about both of these projects throughout the presentation, but here's a high-level overview of what is being maintained today. So let's go back a few steps and just to explain some of the things about Ingress in general. Not talking about NGINX or other implementations here, just the Ingress object. Think of an Ingress as the original way to get traffic into your Kubernetes cluster. It's a very simple and effective tool for basic use cases. It defines rules like, if traffic comes into my application and it needs to be sent to /API, send traffic to the API Kubernetes service. So in this particular diagram here, a Kubernetes cluster, a Kubernetes administrator, user A and user B, they configure the Ingress via the Kubernetes API. Clients connect to your applications A and B, deployed by those corresponding users. So an Ingress controller could be deployed in a pod within the namespace, for example, NGINX Ingress. In this diagram, a single pod is depicted for that Ingress controller. But usually what you'd see is replicas, a couple of pods running the Ingress controller deployed for redundancy. But the Ingress controller uses the Kubernetes API to get the latest Ingress resource in the cluster and then configures the proxy according to these resources. In many cases, you would have a public endpoint. It could be a DNS service or an external load balancer in front of Kubernetes, but that sits in front of an Ingress controller. And this is what usually, this is usually a standard TCP load balancer. It could be a cloud load balancer, a software load balancer, it could be an NGINX instance, or it could be a hardware load balancer, or a combination. So clients A and B connect to their applications running behind the Ingress controller. via the public endpoint, which routes to the Ingress controller. So Ingress is like the engine that makes the Ingress resource come to life, but its simplicity is also its limitation. Because a single Ingress resource could contain rules for multiple applications, multiple different deployments. It could lead to conflicts. There could be multiple teams managing one Ingress controller for all of their applications, and there might be multiple users managing the Ingress controller, and it's quite sensitive. So this is where the one-size-fits-all model kind of breaks down. But the other issue that's very relevant today is that in order to customize the Ingress to do more advanced use cases, we cannot use the original Ingress resource for that. We have to extend it using what we call annotations, non-standard annotations. And these are very specific annotations that are tied to a specific implementation. Ingress-NGINX, for example, has a long list of annotations that contain specific NGINX features. The same for F5's NGINX Ingress controller. There are annotations to achieve certain features that aren't covered in the Ingress object itself. Things like setting cores headers, or adding mutual TLS, or doing regular expression matching, for example. So NGINX Ingress controller, it implements the Ingress API that we just talked about. It's a mature and stable project. We do accept contributions from the community, of course. We do support many annotations similar to Ingress-NGINX, but there are also custom resource definitions as an option as well. And these are another way of configuring the Ingress controller, which is our own standardized way to configure NGINX Ingress controller. So on this slide, you'll see the GitHub repo at the very bottom. You're all welcome to join and raise some feature requests or enhancements to see, or see the roadmap to see what we're working on. So it has been around for a number of years. There are over 150 contributors within the project. It's a proven project in production, and it has things like DNS service discovery, and there are CRDs in there for advanced use cases like I just mentioned. There's also layer 4 support, which oftentimes people don't realize that NGINX is quite a robust layer 4 load balancer as well. So the TCP and UDP are covered in there too, and of course rate limiting and health checking and certain authentication mechanisms are all in there too. So you can deploy NGINX Ingress controller anywhere that runs Kubernetes. You know, it is tested and certified across many different flavors of Kubernetes. It could be an on-prem Kubernetes cluster, it could be a home lab Kubernetes cluster, a cloud-based, enterprise Kubernetes offerings like OpenShift and VMware Tanzu. There are operators in place as well to deploy it, Helm-based operators and so on and so forth. But it can be deployed using Helm charts, manifests, GitOps flows, and so on. Annotations, this is the big one. In my demo at the very end of this, we will go through some annotations and how we can migrate from Ingress-NGINX annotations to the NGINX Ingress controller annotations. But there are a bunch of Ingress controller annotations in there today that are very similar to Ingress-NGINX, and we are actively working on adding many more of those to align with Ingress-NGINX. So stay tuned and keep an eye on the roadmap for that. We're listening to your feedback. We know that there are certain annotations that are very popular. External auth is one of them. So stay tuned, and we will add much more annotations in the upcoming releases. But just to give a quick overview, we are invested in our custom resource definitions for the more advanced use cases. They're very robust, but that being said, it has become very clear to us that the Ingress-NGINX retirement has let us know that the annotations are quite popular, and it's not easy to move away from what you have today with annotations to a different configuration structure. So we've heard that feedback, so we're going to go back and we're going to make some changes to our annotations, update them, include more advanced use cases, and hopefully we can cover the vast majority of use cases of Ingress-NGINX. That said, while there may not be a direct annotation mapping for certain features, That does not mean you cannot configure NGINX Ingress controller to achieve the same outcome. The CRDs, the custom resources, are an option. Obviously, NGINX configuration snippets are very popular as well as configuration or config maps or Gateway API. Maybe now is the opportunity to move to the Gateway API and use a more native way of configuring NGINX. Now, the Gateway API. The Gateway API is a major shift. It's not just a replacement for Ingress. It's a new way of thinking about traffic management. But the most important concept to grasp here is the separation of concerns. Okay. Instead of one monolithic Ingress resource that is managed by multiple teams, we have 3 resources, each with its own role. So a cluster operator can define a gateway and gives that gateway a name, say my application gateway or my production gateway. An application developer then comes along and says, I want my application to use the production gateway. And my rules are X, Y, and Z. This is a much cleaner, safer model. So let's look at this in more detail. So the Kubernetes Gateway API is a standardized set of Kubernetes resources that standardize how you configure and manage your traffic in Kubernetes. So it is intended as a successor to the traditional Ingress API. Ingress was kept intentionally minimal and basic and pushed many features into annotations or controller-specific annotations, which did hurt the ability to be portable or readable. Very difficult to move from one Ingress controller to another, as you might know now. So the Gateway API itself brings these common features, header, path matching, traffic splitting, redirects, authentication, request response manipulation. Those things are brought into the specification or the standard itself. So that reduces the need for custom annotations. A big example that I often use is CORS, setting CORS header. This is a standardized resource in the Gateway API. There is a CORS API within the Gateway API that is a standard that we adhere to from an NGINX Gateway Fabric perspective, and other implementations can do the same. Another one is backend TLS, how we do TLS termination or TLS pass-through. That's a standardized way to achieve that use case with the Gateway API, and many different implementations can make use of that API so that their implementation works with the standard. There's also another for authentication. So there's many more being worked on. Some are experimental, some are in production ready, but you can keep an eye on the Gateway API documentation to see what the team are working on and what's coming. But the Gateway API is also a role-oriented design. So infrastructure and platform teams can manage their gateway classes and their gateways, while the application teams manage their routes or their URL rewriting and multi-tenancy is then supported, and there's a shared infrastructure there. To look at this in more detail, think of the gateway class at the very top as your flavor of load balancer. So this could be when an infrastructure provider or a platform administrator defines a gateway class to represent what implementation are we using. And this could be NGINX as an implementation. The gateway itself is the actual resource that is used to configure an instance of a load balancer. So this could be, a gateway could be a network endpoint with listeners, with ports, with protocol types. Could it be HTTP, TCP, UDP, things like that. HTTP route, TCP route, this is all about the application teams defining routing for their applications that falls under the gateway. So the gateway would be your server block in an NGINX configuration, for example, and your HTTP routes could be your location blocks, for example, and that includes things like adding headers, setting cores, doing authentication, those things. So to make this a little bit more concrete, let's have a quick look at a side-by-side comparison of the two APIs. So this table really highlights the key differences. You can see the Gateway API on the right-hand side it does address many of the pain points of the old Ingress model. It's a much more robust, future-proof solution. There is a separation of concerns here, whereas the Ingress API is a single resource to define everything. One object with annotations and a very complicated routing, which can be very complicated for larger teams where there could be multiple teams managing a single ingress, and that can lead to security problems. It can lead to issues where configurations conflict, and a single ingress mistake could bring down the entire application. Whereas the Gateway API is more of a multi-persona model. So it has individual resources, different focuses. So the gateway itself is the instance of the load balancer. The HTTP route is the routing separate resource entirely. So the separation of concerns is a huge plus here. And also it allows you to extend based on the type of implementation that you're using policy extensions. So if you wanted to do things that don't fall under the standardized Gateway API, you can do so via policy object. So we have this great new API, but we need an implementation to use it, of course. So that's why I'm going to talk a little bit about NGINX Gateway Fabric. NGINX Gateway Fabric is the new and recommended way to get NGINX powered traffic management into your cluster via the Gateway API standard. This has been built from the ground up to be native to the Gateway API. It doesn't have Ingress and Gateway under the same project. It's 100% Gateway API conformant. It has excellent support for things that are very common for Ingress-NGINX users as well. It doesn't rely on Ingress specific annotations. It's very standardized for each use case that is covered. But one of the largest benefits of NGINX Gateway Fabric is that there is a separation of the control plane and the data plane. The control plane, which is a separate pod, separate Kubernetes service, that is responsible for receiving the configuration from the Kubernetes API, the gateway configuration. The control plane converts that gateway configuration into an NGINX configuration. And that NGINX configuration is then applied to the individual data plane pods, so your gateways. So there's a control plane that does the configuration generation, and then the data plane is what handles the traffic. NGINX Gateway Fabric is open source. It is an open source implementation of the Gateway API that uses the NGINX proxy, the high performance data plane under the hood. So it was specifically designed as a forward-looking Gateway API implementation that would replace the annotation heavy approach with traditional Ingress controllers. It supports the gateway class, the gateways, the HTTP routes, TCP routes, and many more. It follows the official spec from the SIG network and conforms to the standard itself. So as you can see in this slide here, it's listed as an official implementation of the Gateway API, and it does support the role-oriented model as well. So the migration from Ingress to Gateway might seem pretty daunting at first, especially for those large clusters with hundreds of Ingress resources and hundreds of annotations and many unique use cases with NGINX snippets everywhere. But there is a tool to help, and it's not a simple find and replace. This tool is smart enough to understand the context and map Ingress rules to the appropriate Gateway API resource. So for example, it can take an Ingress resource and it can generate a Gateway API configuration with the HTTP route configuration as well. So those are separate objects. It's not intended to be a one-click migration tool. It provides some assistance so you could have a gradual migration over time. The idea is that you can use this as a starting point and then set up a Gateway API implementation side by side with an Ingress, ensuring that you have a smooth transition from an Ingress controller to the Gateway API implementation. But when you start evaluating the Gateway API, document your configuration, ask the question, is the Gateway API an option right now? Spin up test environments, get very specific about your edge cases, make sure the different implementations, you have a clear idea on how they handle certain use cases, but take a phased approach to this. And in some cases, you might realize that you're not ready for the Gateway API just yet, and you might use a different Ingress controller implementation. And that's perfectly okay too. As the Gateway API matures, it will start adding those more advanced use cases, things like authentication, things like east-west traffic management, and many more that are being worked on right now. So here's a quick example. As you can see on the left-hand side, we have an Ingress resource, a very simple one that has a couple of headers being set. But using the Ingress to Gateway tool, which you will see later in my demo, there is, you can see that it has generated a gateway configuration based on that Ingress resource, and it has also generated a HTTP route configuration on top of that as well. So you can see on the right-hand side that it's the same configuration within the NGINX proxy. It's the resources are different. We have a gateway that defines your virtual server, your headers, your listeners. And then the HTTP route is responsible for actually doing the routing to the application backend. And you can see we're setting headers there. We're pointing to a service on a certain port, and we're doing regular expression rewrites as well. So to summarize, NGINX is still alive and thriving in the Kubernetes ecosystem. There are many great options out there, and NGINX Ingress controller is actively maintained. In many cases, this might be the best option to move from Ingress-NGINX to another implementation. But in some cases, it might not cover everything. So please raise your feature requests, raise your ideas in our community forum, which I'll talk more about later. But the Ingress controller is mature, it's stable, it's very simple and effective for basic use cases. But there's also the Gateway API. So now might be the time to start evaluating the future of your Kubernetes networking. The Gateway API, NGINX Gateway Fabric, implements that API. It's the evolution of the Ingress controller, and it's 100% native to Gateway API as well. We don't have an Ingress controller and a Gateway API implementation as part of one project. We separated the Gateway API conformed project separate. So both of these are available. The code is on GitHub, and they're available to download right now. Some of the use cases that we would normally see, and this applies to both the Ingress controller and the NGINX Gateway Fabric project. Things like API gateway, path-based routing, monitoring, load balancing, auth, inference extension was a very recent feature we added to NGINX Gateway Fabric, which allows you to route traffic to your LLM workloads running in Kubernetes. So the inference extension is a key highlight of this slide, is that the Gateway API team have put together a standardized way to route to LLM workloads or inference pools running in Kubernetes, and that is now adopted within NGINX Gateway Fabric as well. Now, before I finish with the slides and move on to the demo, the last thing I would like to say is that F5's NGINX Ingress controller does offer a compelling alternative for teams seeking stability and continuity. It is backed by a dedicated team. It benefits from a robust open source governance model as well. So it is licensed under Apache 2.0. We boast contributions. We encourage contributions. We've had contributions from over 150 developers across many different organizations, and we love the transparency and resilience there. But it does use NGINX under the hood, so it is familiar. It has the same NGINX proxy. You can use configuration snippets if you need to. The annotations are similar, maybe not identical, but they are similar. But migration is further simplified through our documentation. We have some guides out there. We have an annotation guide that helps map the annotations. But the idea is to try and reduce the operational friction as much as possible. But it is a good choice for folks looking at migrating from Ingress-NGINX to another implementation. So please check out our GitHub repo, raise any feature requests or issues, and we also include information about our community calls as well, both for Ingress Controller and NGINX Gateway Fabric. So the community forum. We also have a community forum, an NGINX community forum that is open to anyone who would like to join. Please scan the QR code, copy the link, create an account, ask your questions, raise your feature requests. The forum allows you to raise queries, get updates on releases, get links to blog posts that we're frequently adding more and more every week. But it also includes a link to our community calls, which we have as well, bi-weekly for each project, Ingress Controller and NGINX Gateway Fabric. This is open to all users interested in our NGINX projects. Please bring your configurations, bring your YAML files. The team of engineers working on these projects are there, they're on the calls, and we can monitor requests and queries that come into the forum as well. So we're here to help. There are subtopics within this as well. It's not just Ingress Controller or NGINX Gateway Fabric. It's NGINX by itself, NGINX open source, and any other interesting technologies that go with it. So hope to see some of you there. Okay, so right now I'm going to go through a quick demo that goes through the different Ingress resources and Gateway API resources as well, some of the migration strategies, and we'll cover this in 3 parts. We will show an Ingress-NGINX migration to NGINX Ingress Controller, then we'll show NGINX Ingress Controller migrating to a Gateway API. We'll have some annotations in there as well, and yeah, let's get started. Okay, the first thing I'm going to show is that these are the official docs for NGINX Ingress Controller that is actively maintained. And as you can see, it's got a wide variety of features in there. I have the annotations page open here because I'm sure many of you are looking at moving from Ingress-NGINX annotations to other implementations. We have very similar ones within NGINX Ingress Controller. Some of those are very specific to NGINX, of course. Proxy timeouts, proxy read timeouts, proxies. NGINX snippets are a very popular one that's in there. And we are continuing to add more annotations. So I would encourage you to raise your feature requests in our public repository or in the community forum, and we'll take note of them and prioritize them effectively. On top of that, here is an example. So as you can see, on the left-hand side, we have Ingress-NGINX. On the right-hand side, we have NGINX Ingress, which is F5's implementation of NGINX Ingress Controller. You'll notice that many of these annotations are quite similar, not identical, but quite similar. Proxy connect timeout, proxy read timeout, these are very, very popular annotations and NGINX specific parameters that can go into an Ingress resource. Here we have identical mapping in terms of fulfilling the use case. Down here we've got client body max size, which is often used if you have large downloads. You need to configure NGINX to handle larger payloads. Rewrites, of course, these are covered, not identical, but close enough. We have rewrite target, which is essentially the same feature. And then of course use regex, true, and then for Ingress, for NGINX Ingress Controller, we have a case sensitive approach. SSL redirect, so redirecting a HTTP request to a HTTPS request. It's called force SSL redirect here for Ingress-NGINX, and it's redirect to HTTPS here for NGINX Ingress Controller. Close enough. Rate limiting, of course. Basic auth, very popular. Proxy buffers. So you get the idea. There is similar mapping there, but you can use tools out there to help map, and you can check the documentation to see if there's anything in particular that you need to do or anything that's missing, for example. Now we should talk about our custom resource definitions from an NGINX perspective. Annotations are popular. They're used by the vast majority of Ingress controller users. But a few years back, we started building a more standardized way to do configuration with NGINX Ingress controller. So we built custom resource definitions. Some are called virtual server, which is a virtual server object. Some are called virtual server route, which are path-based routing objects. But we have policies as well. So the policy resources allow you to configure more advanced use cases with NGINX Ingress controller. One such example could be mutual TLS. So rather than have 5 or 6 annotations for mutual TLS with Ingress-NGINX, you can create an Ingress MTLS policy for NGINX Ingress controller pointed to your secrets, your CA secret, for example, and you can associate that to your Ingress controller. Another example would be caching. NGINX is a very popular cache proxy as well, and there is a cache policy for NGINX Ingress controller to allow you to configure caching for the Ingress. So you can configure your cache policy and associate that policy with your Ingress resource. Basic auth is an example where, yes, there's an Ingress controller annotation for this within NGINX Ingress controller, but there's also a policy for those using custom resource definitions. If there are any custom resource definitions that you would like to see in the Ingress controller, please let us know. Now, to conclude the demo, I'm just going to show you Ingress to Gateway in action. So as you can see, we have 3 NGINX Ingress controller resources. And let's look at a popular one. So setting headers is a very popular use case for NGINX. And this is what it would typically look like in an Ingress resource. You have an annotation where we set these headers directly within the annotation. And those are applied to the requests that are sent to the Kubernetes service. With Ingress to Gateway, we can convert this Ingress resource into Gateway API resource. So as you can see, going back to the Ingress for a second, these proxy set headers annotations and these routes that you see here, we can see a gateway associated with that configuration. It's listening on port 80 and it has the same host name as the Ingress. This is your gateway object. Under the gateway object, you have a HTTP route, which essentially aligns with the use case of the Ingress resource above. You can see that we have a filter that does request header modification directly, natively within the custom resource definition. So it's a much cleaner approach with no annotations. Let's have another example. So we have SSL redirect, very, very popular from an NGINX perspective. So with this Ingress resource, we have a redirect to HTTPS set to true. So this will ensure that all HTTP requests will get a 301 to HTTPS. We run Ingress to Gateway on this. You'll see we have our gateway again, also listing on port 80 with that host name. Gateways will often be the same in this example because it's a generic Ingress resource on port 80. HTTP route is what we care about right now, which is forcing HTTP to HTTPS. So as you can see, we have a filter, which is a request redirect 301 to HTTPS. Same use case, but now covered under the Gateway API implementation. Now, one more example is protocols that are not necessarily HTTP. You can route to gRPC services pretty easily with NGINX, and you can do so with an Ingress controller. This is an NGINX Ingress controller example where we are telling NGINX via annotation that this service is a gRPC service. So we can convert this to a gateway API configuration. Gateway is the same. gRPC route is not a HTTP route. It's a gRPC route specific to gRPC that routes to that gRPC service. The same use case as the Ingress. So I would encourage you to check out the Ingress to Gateway repo. And the NGINX team built a provider just focused on the NGINX Ingress controller, and these annotations are currently supported. And we will continue to maintain this and add more annotations as more annotations are built within NGINX Ingress controller. So to conclude, here is the community forum. You are more than welcome to create an account, ask some questions, raise some feature requests. You know, this is where we need to hear the feedback from all of you in terms of what the products need, what the projects need, as well as any potential roadmap items that we can share with you all. Okay, thank you very much for listening.